Hi all, welcome to the fourth part of the video lecture on transaction management. Okay, so here we will be discussing the concurrency control techniques. So basically, when multiple transactions are concurrently executing, it should not lead to uh, any conflict because of the interleaved execution of the transaction. For example, if you are looking at the railway reservation system or anywhere, maybe that Talkal time and all, how many concurrent access to the database is happening. So many people from different parts of the world, they will all try to reserve some limited number of tickets, right? So that is, the resources are limited, but many are trying to concurrently reserve it. Okay, so at the same time you have to ensure that the particular seat being reserved by one person is only reserved by that person. If two people are trying to get access to the same seat and they are being allocated also, that is meaningless. So something like that should not happen. So the concurrent execution should always make the schedule, always ensure that even though it is concurrent, that you should not get a feel like that. Everybody should get a feel that he is independently executing, right? So there is no one parallel to him, like that. So that is basically what is the intention of concurrent execution. And also, so if the resources are something common shared by many people, you have to ensure that when one person is accessing it, he is the only one who is using it. So the simpler solution, the similar concept you might know in operating system also, right? How this multiple processes are scheduled in such a way that they are accessing the resources without any conflict, like that. So when one process is accessing on shared resource, so mainly it is for shared resource, you have to ensure that others are not given access to the same item. So maybe if it is so typically we have conflict with respect to read and write. If many people we will typically allow read operation, that is fine. But when it comes to read and write, you have to ensure this. Okay, so the simple solution is definitely that locking, right? So you can lock this variable, this particular resource for a given transaction. You can say that as it is locked by someone else, you are not getting access to it. So that's all. So basically it is just a variable or flag is what we are using, and the flag is 1 means it is being locked. If it is 0, it is not locked and I can access it, like that. Okay, so that is the kind of thing. And when you are the lock as well as unlock, those operations, that should happen in an atomic way also. So because when you are trying to lock something, in between if there is some interleaving and someone else is getting access, so that will lead to wrong execution. That should not be the case. So that is on solution. And there are something else being used in database called a timestamp based protocols are also there. But you are supposed to, as per the syllabus, two phase, locking protocols are only introduced. The timestamp protocol you don't have to study. So that about it. Now quickly read it. The concurrency control techniques are used to ensure non-interference or isolation. So that is the terminology, property of concurrently executing transaction. The most of this technique ensure the serializability of the schedule also. Serializability is something that we discuss separately, but if you have the schedule where the concurrency control techniques are correctly incorporated, the schedule is will be by default serializable also. Okay. Mostly it is so. So one popular protocol used for this purpose is two-phase locking protocol. Say in a growing and shrinking, two different phases we will do this locking as well as unlocking in a systematic way. We will see that, and which employs the technique of locking data item basically. So before moving on to two-phase locking, we will see what is the concept of locking. Then we will see two-phase locking and its variation. So it employs a technique of locking data items to prevent multiple transactions from accessing the item concurrently. So locking protocols are used in some commercial DBMS, but they are considered to have a high overhead. So this locking as well as unlocking, that process and all, is typically it involves some overhead. So there is a better technology actually. So there is another set of concurrency control protocol that uses the concept of timestamp, so which is a unique identifier for each transaction that is being generated by the system. Okay, so timestamp values are generated in the same order in which this transaction starts execution, and accordingly you can restrict the concurrent access, everything. But anyway, this concurrency control techniques based on timestamp is not given in your syllabus, so I will not be covering. So those who are interested can read from the textbook. So we will just focus on the two-phase locking protocol only. So before moving on to the topic, we have to see what is a lock and what are different types of lock, etc. Okay, so two-phase locking technique for concurrency control. Some of the main technique used to control concurrent execution is locking data. What is a lock? You know, a lock is a variable associated with the data item that describe the status of the item with respect to possible operations that can be applied. So whether you can access it or not. If it is already locked, it will not be given access to some other transaction. Okay, so generally there is one lock you have to maintain per data item. That is a type of overhead we are having. For every data item you have to maintain this lock variable also, and locks are used in as a means of synchronizing the access to concurrent transaction to the database system. There are several types of lock. Mainly we have this binary lock and shared lock or exclusive lock, okay, which is also known as read write lock. So we will start our discussion with the binary locks. As the name says that it is just having two values, say 1 and 0, like that. A binary, it's assuming binary value, so that is a basic thing. So it is having two states, locked as well as unlocked. Say locked is represented by 1 and unlocked is represented by 0. So a distinct lock is being associated with each data item, like I already told you. So now if the lock value is 1, that says that it is we cannot access the data item for some other transaction. If it is 0, it is really it is available, it is not locked, it is given to given access to some other transaction. Okay, so we refer to the let's see some small algorithm for accessing some data based on binary lock, and where we will use this lock of x to indicate that the current lock value of x. So lock of x can be 0 or 1. So what is the lock value lock associated with x, that is being represented by the this notation lock of x. So we refer to the current lock value or the lock associated with the given data item like this. And lock item is a procedure that will set a lock value for that item as 1, and unlock will make it 0. Okay, clear. Now that about it. And lock of x is equal to 1 means it is so whenever a new transaction is coming and is trying to lock an item, and when it called that lock of x, it saw that it is already 1, means someone else is already locked it, so he has to wait. Okay, that's all. If it is 0, he will get access to this. And similarly, when you are unlocking, you have to make this lock of x to 0. Okay, so it's definitely going to ensure mutual exclusion, or only one transaction can access this common shared data item at any time. So mutual exclusion, you might know this terminology in OS, where we have that critical section and insert critical section. In a mutually exclusive way, we are giving access. The same concept only, but here we are talking with respect to the database transactions. So lock and unlock operation for binary lock, this is what we explained. So this is the locking procedure and this is the unlocking procedure. So locking procedure, you have to lock an item for you for the given transaction. So before that, you will check whether the current status of the particular lock associated with the variable. So that is being returned by lock of x. If it is equal to 0, that means the item is unlocked, right? If the item is unlocked, I can lock it by making this lock of x as 1. Now else, in the sense, if it is locked by someone else, okay, wait until this lock value becomes 0. Okay, and then lock manager is a module that will keep checking whether the lock is free or not. If it is free, it will wake up the transaction, in the sense it is waiting. So where it can wait, maybe in a queue, in a so if and that is a fair procedure. So whoever is trying to access the data item which is being locked by someone else, everybody will be waiting, say inside a queue, and maybe without wasting any resources, it can go to the sleep mode also. So that will be wake up by the lock manager module, which will be alerted whenever the system the particular lock as with the variable is 0. Okay, so that will happen automatically. So like that. So wait and go back to B and do that checking again, like that. Okay. So it's kind of persistently that checking is needed. Again, that is not a good scenario. We can improve it, but this is just a basic trivial algorithm. Okay, so this is looking like a polling kind of thing, but anyway, we can improve. So now unlock is simply making that lock variable as 0, and at the same time you have to ensure that, the lock manager, whenever this lock is set to 0 for a given item, it has to check whether someone else is waiting for the lock or not, maybe in a queue, and if that is the case, wake up one of the waiting transaction. So what data structure you can maintain on the background is up to you. So queue is something typically maintained as the default option. Okay, so that about it. Now you can see in the critical section, without any interleaving, you can have access. So the wait command, typically we will maintain this queue as a wait, where the transaction will be waiting, typically in a waiting queue, like I explained. Okay. So binary valued variable lock can be used, and so typically the lock record could be having a structure like what is a data item for which you want this lock, and the status of this lock variable to locked or unlocked, say 1 or 0, and who is locking the particular item. So what is the item, say item number x, so it will be something of the form item number item is x and the lock value is 1. So that is done by transaction t1 like that. Okay, so this kind of a record we will maintain typically, and you can use hash file organization for keeping these records and all. And typically we use a lock manager subsystem to keep track of this locking and all, and accordingly so this lock manager will be waking up the transaction whenever the lock is free like that. Okay, so that about it. And in the simple binary locking system that we explain here, the transaction is supposed to follow the rules, and straightforward rules only. What is the first thing? A transaction T must issue the operation lock of x before read. So before reading any item, as well as writing any item, you have to ensure this lock, right? So you should get exclusive access to the item, then only you are allowed to read it or write it. A transaction T must issue unlock item after the read as well as write operation of the item. You have to ensure unlock, so that it is now available to some other transaction. Now transaction T will not issue lock item if it is already locking an item. So I already have that item, again asking to lock it is meaningless, right? Similarly, the transaction T should not issue unlock item unless already holds lock item. Something if I locked, I can unlock. I am unlocking something which I am not locked, that is meaningless. Okay, so like that, straightforward things only. So these rules can be enforced by the lock manager module of the database management system. So between the lock and unlock, the operations the T is set to hold the lock. So from the point at which the item is locked and till it is unlocked, in between the transaction is holding the lock, right? At most one transaction can hold the lock at a time. So that is important when it comes to binary lock. But we have variations also, like the next video we will discuss shared lock, and that time many transaction may hold an item with a common lock, maybe by using some so when it comes to read operations, okay, that we will see later. So thus no two transaction can access the same item concurrently, because lock is at any time with a single transaction only. Yeah, that about it. So here we just introduced what is this concurrency control protocol and what is happening there, and two major approaches, the concurrency control by two-phase locking as well as concurrency control by timestamp. But anyway, the timestamp topic is not there in your syllabus, and two-phase locking is there, and there itself what is a lock is, and what are different types of lock. The binary lock is what we discussed, and something a better version is shared or exclusive lock, and that we will see in the next video lecture. Yes, thanks for watching.